Hello all, so today we are talking about water. And water is the most important nutrient except for minerals, the simplest nutrient. The average individual can survive several weeks without food, but only a week without water. Rapid losses of water and electrolytes through dehydration or diarrhea can be fatal in an even shorter period of time. So physically active individuals are aware that a hot and or humid environment can impair their performance. Environmental and metabolic heat results in loss of body water and electrolytes, which compromises the body's ability to dissipate heat and regulate core temperature. At best, loss of fluid and electrolytes will impair performance. Inability to regulate your core temperature can lead to heat illness, the most extreme form of which can be fatal. So this chapter discusses the roles of water and the key electrolytes, sodium, chloride, and potassium in fluid regulation and performance, the effects of water and electrolyte loss on performance, as well as the strategies for proper hydration before exercise and proper rehydration during and after exercise, as well as the recognition and prevention of heat illnesses and the role of fluid and electrolyte balance, diet, and exercise in high blood pressure or hypertension prevention and management. So let's get to it. So if we look at how much water we need daily, AI values for water intake have been established as 3.7 liters and 2.7 liters, or 3.9 and 2.9 quarts for average males and females respectively, based on 2005-2010 National Health and Nutrition Examination Survey data. Janowski and colleagues reported that a large percentage of older people, 75 years and older, and children aged 4 to 13 failed to meet recommended AI water intake. Adults, but not children, generally exceed the 1 liter or 1,000 calorie water intake recommendation. Somewhat lower AI have been established for teenagers and children. The actual requirement for a given individual depends on factors such as body mass, health, age, environmental conditions, and physical activity. Water requirements may be increased substantially during exercise, particularly under warm environmental conditions like we have here in Corpus Christi. So if we look at the body water balance that is to be maintained when the output of body fluids is matched by the input of water, Janowski and others note that water, soda, alcohol, caffeinated beverages, milk, fruit juices, and sports drinks contribute about 75 to 84% of water intake, with the remainder coming from food. So if you have someone who doesn't like water in particular, they can have other sources, and that's important. A small amount of water is lost in the feces and through the exhaled air and breathing. Insensible perspiration on the skin, which is not visible, is almost pure water and accounts for about 30% of body water losses. Perspiration or sweat losses may be increased considerably during exercise and or hot environmental conditions. Urinary output is the main avenue for water loss. It may increase somewhat through the use of diuretics, including alcohol and caffeine. So if we look at fluid intake of beverages such as water, soda, milk, juice, coffee, and tea products, about 80% of total water needed to replenish losses. Valton notes that we obtain significant amounts of fluid from caffeinated and alcoholic beverages such as coffee and beer. Gives you a good reason to go out to the bar today, right? Although both beverages contain diuretics, the Consumers Union noted that if you're used to drinking caffeinated or alcoholic beverages, the diuretic effect of each may be offset by the amount of fluid in the beverage, and you probably gain more fluid from beverages such as colas, coffee, and beer than you lose. About 20% of our daily total water intake comes from the foods we eat. Solid foods also contribute as a water source in two different ways. First, food contains water in varying amounts. Certain foods such as lettuce, celery, melons, and most fruits contain about 80 to 90% water, whereas meats and seafood contain about 60 to 70% water, even bread, and apparently dry food contains 36% water. Second, the metabolism of carbohydrate, fat, and protein for energy produces water. Fat, carbohydrate, and protein all produce water when broken down for energy. You may recall the reaction when glucose is metabolized to produce energy, with one of the byproducts being metabolic water. And as I mentioned before, the AI established for water under normal environmental temperatures and activity levels for adults age 19 and over, for males about 3.9 quarts, and for females about 2.9 quarts. So if you're getting about 3 to 4 quarts, you're doing a great job. This figure is just looking at the estimate of water balance, your intake versus your output, in a woman in particular. We primarily maintain our volume of body fluids by adjusting water output to intake. And as you can see, most water comes from the liquids we consume. Some come from the moisture in more solid foods, and the remainder is manufactured during metabolism. Water output includes losses from the lungs, urine, skin, and feces. So what else is in the water we drink? The tap water we drink, although generally safe, is not pure. Solutes entering drinking water from natural geological formations include minerals such as calcium, magnesium, fluoride, iron, sodium, and zinc. Calcium and magnesium may be beneficial. Fluoride is beneficial in preventing dental caries and is added to the municipal water supply, but too much can stain teeth and adversely affect bone health. Some minerals such as excess sodium, arsenic, and lead may lead to various health problems, whereas others such as calcium and magnesium may be beneficial. Brown and Margolis stress that all sources of lead should be controlled or eliminated because lead accumulates in the body and there is no safe blood level in children. Of greater concern to public health in economically developed nations are human-made solutes in the water supply. Murray and others identified 3 broad classes of emerging contaminants as industrial chemicals, pesticides, and pharmaceutical or personal care products. If you're concerned about your water, know that some health professionals suggest a water filter as the best alternative. Water filters added to your tap may help unwanted substances such as chlorine or chlorinated byproducts. Some water filters are designed to eliminate lead and mercury, and others can even trap parasites. Many are designed to eliminate lead and mercury, and others can even trap parasites. Many types of water filters are on the market, so if interested, have your water analyzed and then seek an appropriate water filter to help purify your tap water. You can get more information on the quality of your water supply. You can contact your local water utility and ask for the latest water quality or consumer confidence report. And this is a website that you can go to. Under the Safe Drinking Water Act, the Environmental Protection Agency, or EPA, provides a list of contaminants and their maximum contaminant level. Most, but not all, municipal water treatment facilities conform to these standards. The EPA also provides guidance for special populations such as pregnant women, infants, and children, and the elderly regarding exposure to contaminants in drinking water. Bottled water is the current rage. The International Bottled Water Association, yes, there's an association for that, reported sales of $11.8 billion in 2012. A 2013 New York Times article by Stephanie Strom reported that bottled water sales are projected to overtake carbonated beverages sales by 2020. The FDA regulates bottled water as stringently as the EPA regulates tap water. Artesian water is drawn from a well that taps a confined aquifer. Mineral water comes from a protected underground source and may contain greater than 225 parts per million in minerals from a geological underground source. Spring water flows naturally from an underground source, whereas purified water is produced by distillation, deionization, or some comparable process. And then sparkling water contains carbon dioxide in the same concentration after treatment as before. Vitamin, herbal, nutraceutical, fitness, and oxygen waters, the last of which will be discussed later in the chapter, are also in the marketplace. About 85% of bottled water manufacturers belong to the IBWA, which sets even tougher standards for its members than the FDA. Individuals who drink bottled water should be aware that approximately 25% is simply tap water that has undergone a purification process. The nation's 2 best-selling bottled waters, Aquafina and Dasani, are purified municipal water. Also, surveys have shown that most bottled waters do not contain fluoride. For example, La Luminaire and Ayres reported that only 5% of 57 samples of bottled water contained fluoride within the recommended range. Check bottled water labels for mineral content. The FDA is also seeking legislation requiring that bottled water manufacturers list contaminant levels on bottle labels. So bottled water isn't cheap. One gourmet bottled water bling is marketed at $55 or more per bottle. Other specialty waters are less expensive, but a bottle of vitamin water may cost well over $1, whereas a glass of water with an inexpensive multivitamin or mineral tablet will provide the same benefits but cost 10 times less. The Consumer Union indicates that you do not need any of the specialty waters to replenish fluids, but if their taste encourages you to drink more, they may be worthwhile, especially if you normally do not drink adequate fluids. When is water stored in the body? As illustrated in Figure 9.2, water is stored in several body compartments but moves constantly between compartments. The reference 70 kilogram or 154 pound man is 60% water or 42 liters. The average female is approximately 50% water. More water is found in muscle and non-fat tissue than in fat tissue, so water content can vary from 40% in obese to 70% in very lean individuals. In the average male, approximately 60 to 65% or 25 to 28 liters of total body water is intracellular water, while the extracellular water compartment makes up the remaining 35 to 40%. The extracellular water is further subdivided into the intercellular or interstitial water between or surrounding the cells, the intravascular water within the blood cells, and miscellaneous water compartments such as the cerebrospinal fluid. Water compartments are measured using the indicator dilution method, where a known quantity of an appropriate tracer that cannot leave the compartment is injected into the space. For example, deuterium oxide is a common tracer to measure total body water. Other tracers are required to measure water volume in specific areas. After equilibration, a compartment sample is analyzed for the concentration of the tracer. Compartment volume is calculated as a tracer mass divided by a sample tracer concentration. So here you can see body water compartments in the 70 kilogram or 154 pound male. As illustrated by the blue arrows, there is a constant interchange among the different body water compartments. The water inside the body cells, the intracellular water, is important for cell functions. The extracellular space includes intercellular, intravascular, and miscellaneous, which would include the cerebrospinal fluid. The intracellular water constitutes about 60 to 65% of the total body water, while the extracellular water constitutes the remaining 35 to 40%. In the blood, some of the water is intracellular in the blood cells, while the remainder is extracellular in the plasma. Decreases in blood volume or intravascular water may adversely affect someone when they are dehydrated. Water is held in the body in conjunction with protein, carbohydrate, and electrolytes. Protein in the muscles, blood, and other tissues help bind water to those tissues. Plasma proteins, notably albumin, bind approximately 15 milliliters of water per gram and account for colloid oncotic pressure, which pulls water into the vascular space. As discussed in Chapter 4, muscle glycogen has considerable amounts of water bound to it, about 3 grams of water per gram of glycogen, which may prove to be an advantage when exercising in the heat. In essence, the metabolism of 350 grams of carbohydrate during exercise will provide nearly 1 liter of water for body functions, as documented by Rogers and others. The sodium in the extracellular fluid, including sodium in the vascular system, also attracts water. Proper water and electrolyte balance within these compartments is of extreme importance to the athletic individual. Fluid shifts, such as decreases in blood volume and cellular dehydration, both of which may develop during exercise in the heat, could contribute to the onset of fatigue or heat illness. So how is body water regulated? Johnson notes that maintaining body water and sodium balance is so critical to health that the central nervous system has developed specific neural patterns, fostering an appetite for both water and salt. Body water is maintained at a normal level through kidney function. Normal body water is called normal hydration or euhydration. Dehydration, the loss of body water, results in a state of hypohydration or low body water level. Hyperhydration represents a condition in which the body retains excessive body fluids. Normal kidneys function very effectively to eliminate excess water during hyperhydration and conserve water during hypohydration. Because water is so essential to life, it is indeed fortunate that the body possesses an efficient mechanism to maintain proper water balance. Homeostasis is the term used to describe the maintenance of a normal internal environment so that the body has the proper distribution and use of water, electrolytes, hormones, and other substances essential for life processes. Homeostatic mechanisms are essentially feedback loops consisting of commands from the CNS to fluid and thermoregulatory organs, or the efferent flow, in response to communication from the tissue, the afferent input. A detailed discussion is beyond the scope of the text, but several feedback loops to regulate water balance, electrolytes, and temperature are illustrated in Figure 9.4. If these feedback devices are functioning properly, the body usually has no problem in maintaining the normal function and chemical composition of its fluid components. The main feedback device for the control of body water is the osmolality of the various body fluids. Osmolality refers to the amount or concentration of dissolved substances known as solute and a solution. In a body, a number of different substances affect osmolality, including glucose, protein, and several electrolytes, most notably sodium. These substances are dissolved in the body water. 1 mole of a non-ionic substance, such as glucose, dissolved in a liter of water is 1 osmol. 1 millimole is 1 millismole. However, a mole of a substance that can dissociate in 2 ions, such as sodium chloride, is equivalent to 2 osmoles. 1 millimole of sodium chloride would be 2 milliosmoles. Osmolality is expressed in milliliters of osmolality per kilogram of body mass. Wow. Okay. Osmosis and tonicity, when this figure is demonstrating osmosis and tonicity, when the extracellular fluid contains more electrolytes or other osmotic substances, it is hypertonic to the intracellular fluid, and water will flow from the intracellular fluid space to the interstitial fluid plus intravascular fluid that makes up the ECF space. And the cell decreases in volume. In other words, water flows to the area of greater osmotic pressure. When the solute content, and that's demonstrated in figure A, when the solute concentration is the same in the cell and outside the cell, there is no net gain or loss of water from either space. Therefore, no change in the cell volume. You see that in figure B. In C, you see when the ICF contains more electrolytes or higher osmotic pressure than the ECF, water will flow into the ICF space from the ECF space, and the cell increases in volume. And this figure is demonstrating one feedback mechanism for homeostatic control of body water and blood volume. Other feedback mechanisms operate concurrently. For example, the hypothalamus also stimulates the thirst response to increase fluid intake. So you have a stimulus such as excessive sweat loss that has an effect on the blood, which is losing water and increasing osmolality and becoming more hypertonic. That sends signal to the hypothalamus, where osmoreceptors detect increased blood osmolality and respond by stimulating the pituitary gland. The pituitary gland then is stimulated. It releases antidiuretic hormone, or ADH, into the circulation, which causes the kidneys to increase water absorption and affects are seen on the blood where water is absorbed from the kidneys to help maintain body water and blood volume. So, how do I know if I am adequately hydrated? Osmoreceptors and other mechanisms also may stimulate the sensation of thirst, which is usually a good guide to body water needs and is effective in restoring body water to normal on a day-to-day basis. Some sports scientists contend that thirst may also be a good guide to hydration status during exercise. For example, Fudge and others studied elite Kenyan runners during a 5-day training period and found that they remained well hydrated day to day with ad libitum fluid intake. However, as shall be noted later, it may be advisable to start consuming fluids during exercise under warm conditions before you become thirsty. One of the best guides to indicate a state of normal hydration is the color of your urine. In general, it should be a clear, pale yellow. A deeply colored yellow urine, usually excreted in small amounts, is indicative of a state of hypohydration. However, vitamin supplements containing riboflavin may cause the urine to appear yellow and suggest a state of dehydration when the individual is actually euhydrated. So what are the major functions of water in the body? Water is essential if the other nutrients are to function properly within the human body. It is the solvent for life. It has a number of diverse functions that may be summarized as follows. Water provides the essential building material for cell protoplasm, the fundamental component of all living matter. Because water cannot be compressed, it protects key body tissues such as the spinal cord and brain. Water is essential in the control of the osmotic pressure in the body or the maintenance of a proper balance between water, interstitial and intravascular proteins, and the electrolytes. Any major changes in the electrolyte concentration may adversely affect cellular function. A serious departure from normal osmotic pressure cannot be tolerated by the body for long. Water is the main constituent of blood, the major transportation mechanism in the body for conveying oxygen, nutrients, hormones, and other compounds to the cells for their use, and for carrying waste products of metabolism away from the cells to organs such as the lungs and kidneys for excretion from the body. Water is also essential for the proper functioning of our senses. Hearing waves are transmitted by fluid in the inner ear. Fluid in the eye is involved in the reflection of light for proper vision. For the taste and smelling senses to function, the foods and odors must be dissolved in water. Of primary importance to the active individual is the role that water plays in the regulation of body temperature. Water is the major constituent of sweat, and through its evaporation from the skin of the surface of the skin, it can help dissipate excess body heat. Of all the nutrients, water is the most important to the physically active person and is one of the several that may have beneficial effects on performance when used in supplemental amounts before or during exercise. Hence, the athletic individual should know what is necessary to help maintain proper fluid balance. So can drinking more water or fluids confer any health benefits? Although the major functions of water have long been known, nutrition scientists now theorize that drinking enough water may have specific health benefits. In the review of available literature, Lotan and others suggest that low fluid intake may be associated with urinary system diseases. Dranowski and colleagues reported plain water accounts for only 30 to 37% of total dietary water of U.S. adults. Coffee, tea, and other beverages contributing to total water intake may also have potential positive or negative effects on health. Caffeine, which is discussed in Chapter 13. The Consumers Union indicated a similar relationship between water intake and colon cancer. Theoretically, increased water intake could flush carcinogens from the urinary tract and colon. Some dietitians indicated that increased water intake may help one reduce excess fat in a weight control program by increasing the sensation of fullness and suppressing hunger. Research suggests that this may be the case. DeCastro reported that subjects consumed fewer calories, at least on a short-term basis, when eating foods with high water content. High-volume, low-energy foods may be an integral part of a weight control diet. Other benefits might include less chance of kidney stones, fewer asthma attacks, and better oral health, all of which are attributed to better hydration. Although you consume water in a variety of beverages such as juices, sodas, or Coffee. Scientists recommend water itself. It is cheap and calorie-free. So some key points. The average adult needs 2 to 3 quarts of water per day. Maintaining water balance primarily by drinking fluids, but substantial amounts of water are also obtained from your solid foods in the diet. Caffeine is not as potent a diuretic as was once thought, and beverages containing caffeine, such as coffee and cola sodas, may augment daily fluid intake. Normal water levels in the various body fluid compartments are maintained by a feedback mechanism involving specific receptors for osmotic pressure, the antidiuretic hormone ADH, and the kidneys. Water has a number of functions in the body. One of the most important benefits for people who exercise is the control of body temperature. Plain water is an effective and inexpensive means to help maintain fluid balance in the body. Some beverages, such as pure fruit juices, may provide healthful nutrients, whereas others, such as alcoholic beverages, may pose a health risk.